Good evening, everyone. Time for another sleepy math for you. Today we're going to be talking about derivatives, specifically the power rule. I'm not going to do any of the derivative stuff. Tonight's just the power rule with some examples. So even if you don't know calculus, you can wrap your head around this one because the power rule is one of the easiest things that there is. So basically what a derivative is a function that describes the slope. That's right, describes, we use m for the function at any given point. So for example, if you had a slope like, I should say a function like x squared, and you wanted to know what the slope of the function was exactly at the value of 1, there's a process you can do to figure out what that would be. And let's actually use that one as our first example. So f of x is equal to x squared. And the way the power rule works for derivatives is this. If f of x is equal to x to a number n, and the derivative function, which reads as f prime of x, is equal to n times x to the n minus 1. And the beautiful thing about this is it always works. Even if we put coefficients in front of x, even if n isn't an integer, if n is positive, it's negative, it doesn't matter, always works as long as n is some number. So back to the task at hand. F of x is equal to x squared. Then f prime of x is equal to, bring the 2 out front, times x to the 2 minus 1, which is 1, or I can just leave this as 2x. Now, taking a little bit of an aside, when I was describing what a derivative function does, I said what happens when x is equal to 1. Well, then f prime of 1 is going to be 2 times 1, which is 2. So the slope of the function f of x is equal to x squared. The slope is equal to 2 at an x value of 1. So that is derivatives, the power rule anyway, the easiest rule. Second easiest rule, if you know about Euler's number. That one's great. That's not enough to do a whole video on. I'll just tell you real quick, why not? F of x is equal to e to the x. F prime of x is equal to e to the x. I always like to say e to the x is its own grandpa. So it's a beautiful function in calculus because the derivative and the antiderivative is itself. Anyway, let's try a slightly more difficult example of the power rule. And let's go 3x to the 5th. So if f of x is 3x to the 5th, then the derivative, f prime, is 5 times 3x to the 4 minus 1, which is like 15. Oops, I did the computation in my head on accident. It's 3x to the 5 minus 1, which will be 4. So we get 5 times 3 is 15, x to the 4th. And the reality is I don't usually write that part. So if I was going to do something like f of x is equal to negative 6 x to the 15th, then f prime of x is going to be negative 90 x to the 14th. No reason to write it down in multiple steps. Okay, that's great. That's all positive integers. What happens when we have negatives? Let's say f of x is equal to, let's go x to the negative 3. Well, f prime of x then is equal to, bring that power up front and subtract 1, negative 3x to the negative 4. The reason this is useful is x to the negative 3, you might see written as 1 over x cubed. And x to the negative 4 is like 1 over x to the positive 4. And then I can put that negative 3 up there. Sorry, that's a really ugly looking 4. If I zoom in a little, I can do this a little better. There we go. So negative 3 over x to the 4th. So there we are working with negatives. It's really not drastically more difficult, certainly not if your goal is to just simply leave it in the form that we had right here. What about fractions, okay? Well, fractions come in a couple of different flavors. First, let's pick something like f of x is equal to 2x to the 5 halves. Well, then f prime of x will be, so I have to do 5 halves times 2, which is like 10 over 2, which is 5. X to the, well, 5 halves minus 1 is like taking away 2 halves, so we get 5x to the 3 halves. That's not so bad. If we have, actually, let's do the same one that we just had, make things a little bit more interesting. I'm going to take the second derivative, f double prime of x. 3 halves times 5. What we wind up with for our numerical coefficient is 15 halves x, and 3 halves minus 1 half is 1/2, which I can write as 15 halves times radical x, or I could have put that radical x in the denominator. So the 1/2 power and the square root means the same thing. In calculus, when you're actually doing your work, I pretty much never recommend writing the square root. I always write things as fractional exponents, and this is the very reason why. Dealing with fractional exponents is pretty easy. Dealing with radicals, sometimes you get a little bit stuck in your head. At least I do. All right, let's come back to how we had it, and let's do a third derivative. So f triple prime of x. So now we have 1/2 times 15 halves. That's going to be 15 fourths times x to the negative 1/2. Now things are getting really weird, but if we think about what this means, oops, let's undo that one. 15 is my numerator, 4 is part of my denominator. X to the negative 1/2 is like 1 over x to the positive 1/2, or 1 over radical x. So I can just make it 15 over 4 radical x. I know people who are maybe in the earlier stages of high school math, you might say, you can't have a radical in the denominator. Well, I feel like at some point that stops being a rule. Let's leave our radicals in the denominator, and that's that. Okay, last thing. F of x is equal to 7x to the 0.2 decimals. Uh-oh. Actually not uh-oh, because the rule works no matter what, and that's what's so beautiful about the power rule. So 0.2 comes out front, multiplies 7, that becomes 1.4. So f prime of x is equal to 1.4 x, and then 0.2 minus 1 is negative 0.8. So 1.4 x to the negative 0.8. Might not make a ton of sense to you, that final answer, but it's correct. And that's why these are so easy to do. All right, well, I hope you enjoyed, and please do subscribe to my channel. It would mean a lot to me and means a lot to the channel. And if you feel so inclined to like and share as well, I'm not going to tell you not to. Anyway, have a great night.